this video, we're going to take a look at section 1.3 on collecting sample data, whichever way you want to say that. All right. In an observational study, observations and measurements are made of specific characteristics without attempting to modify the subjects being studied. So in an ideal observational study, your act of observing does not change the behavior of that which you are observing. You want to observe people in their natural state and hope that they don't modify their behaviors based on knowing that they're being observed. So you really don't want to change things when you are conducting an observational study. Contrast that with an experiment. In an experiment, treatments are applied, so you make changes to the thing that you are studying, and then the effects of that treatment on the subjects are observed. So what can be confusing about this is notice that in the definition of experiment is the word observe. Just like in the definition of observational study, there's observe. So in both cases, you are watching to see what's happening. So you have to be careful about that. The major difference is that in an experiment, you intentionally modify a group's situation in some way, and then see how that affects their situation later on. So you're trying to monitor how the change you're making changes their behavior or their outcomes or whatever it is that you're measuring. Oftentimes in an experiment, you'll have a control group that does not experience those changes and a treatment group that does. And then you can compare the different outcomes of the control group with the treatment group to see if there was any distinguishable differences. All right, and so that is observational study versus experiment. So on the homework, you'll have some questions that will say, is this scenario an observational study or an experiment? And the key thing that you want to look for is, are the people conducting the scenario intentionally modifying something that's being observed to see the effects of that modification? If not, then it's an observational study. But if they are, it's an experiment. Okay, hopefully I said that right. A random sample. So we have to be careful about how we use the word random because it's made its way into the general lexicon of the culture. So people say, oh, that was totally random. What just happened over there? But in statistics, it has a very precise meaning. And so when we say random in statistics, we're not just, throwing out a description of something weird, because a lot of people use the word random as, oh, that was kind of a weird thing that happened, like that was random. But random in statistics means this. A random sample is one in which each member of the population has an equal chance of being selected for the sample. All right, so for something to be truly random, it has to have an equal chance of occurring, right? So a random sample is one in which when you go to select the members for your sample, each member of the population has an equal chance of being selected to be in that sample. That makes it a random sample. It doesn't mean arbitrary. So sometimes I think students think, well, if I just kind of pick this person over here and this person over here and this person over here in some arbitrary way that it makes it random, but it may not necessarily be random just because you did it using some arbitrary rule. And so we'll talk more about different sampling methods as we go through the video. And some of the different sampling methods will have will have arbitrary elements to them, but they aren't necessarily random samples, because for it to be random, it has to meet this very specific criteria, which is that each member of the population has to have an equal chance of being selected for that sample in order for it to be called a random sample. And this is really sort of the gold standard of creating samples, of collecting samples, is you want to do it in as random a way as possible, because that gives you the best chance of getting a sample that's representative of the population. All right. Now, contrast that with this slightly different concept of a simple random sample. And it's kind of a misnomer there because it's a little bit more complicated to understand the concept, I would think, than what we just talked about. A simple random sample of size n, so that's the number of people or items that will be in your sample, is one in which each possible sample of size n has the same chance of being the sample selected. So for random sample, we're talking about the individuals each having an equal chance of being selected for the sample. But for a simple random sample, each sample of that particular size that could possibly be created has an equal chance of being the sample that you end up creating, right? So it's a difference between the individual having an equal chance and groups of size n all having an equal chance of being the sample that you get. So with random sample, it's about the individual having an equal chance. With simple random sample, it's about all groups of the same size having an equal chance of being the sample. We'll do at least one example later that really does a good job of drawing a distinction between those two concepts, because you might think, what's the difference? It sounds like they really would mean like it would be the same in either case. Like you could call it either one and it would be true in either case. But there are scenarios where you can have a random sample, but not a simple random sample. And so I have an example that I'll share later of that. Okay. So here are some other sampling techniques that we could use. These are not necessarily random samples. So in systematic sampling, the population is arranged effectively in a line, and then every kth member, every kth member of the population is selected. So I like to think of this systematic sampling as like a conveyor belt type sampling, where every member of the population is placed on a conveyor belt, one after the other, and every 10th one you select for the sample, or every 8th one, or every 20th one, whatever number you want to pick, you take every 20th one as a member of your sample and do your measurements or whatever. This might sound arbitrary, right? It's like, well, you could do every 8th one, every 10th one, every 20th one, whatever number you wanted to pick to collect your sample. And the number you pick might sound like an arbitrary number, but this is not a random sample. Because if you're going to pick, for example, every 10th member of the population to be in your sample when they're on this conveyor belt, then the 9th person on that conveyor belt has 0 chance of being selected for the sample, right? And the 10th person has a 100% chance of being selected for the sample. So they do not have an equal chance of being members. And members is maybe a bad word to choose there, but they do not have an equal chance of being selected for the sample. The 9th person and the 10th person, their odds are different, right? The 9th person has no chance, the 10th person has a 100% chance. And so that's not random. So imagine that once you've organized your population on this conveyor belt and you make that choice about how many you're going to count before you take a selection for your sample. Once you've made that arrangement, not every person in that population has an equal chance of now being selected. So it loses its randomness at that point. All right. With convenience sampling, the sample is selected by the most convenient means necessary. So an example that I will often give in class of this is if I wanted to survey the students at Dodge City Community College about how they feel about tuition increases or something. The proper way to do that would be to get a list of all the students at Dodge City Community College and find some method of randomly selecting from that list and then track those students down, get them to respond. Be a lot of work, right? What would be more convenient for me is just to ask the students in my classroom, right? So you're already in my classroom, you're right there. I could just ask you, how do you guys feel about the tuition increase? And write down your results. That is not a random sample. Again, it might sound random if I'm just asking whoever's nearby. It might seem arbitrary, but that doesn't fit the definition of a random sample because students who are not in my class have 0 chance of being selected for the sample, whereas students who are in my class have a 100% chance of being selected for my sample. So again, different probabilities of being in the sample for different members of the population means it can't be random. All right, so that's convenient sampling, is just collecting data from wherever it's most convenient, but that can be unreliable, right? Because if I'm only asking students in my class, especially like a statistics class, that set of students are going to be different than students that might be in other classes. They might have different perspectives, right? Usually for statistics students, they're sophomores, they're about to graduate. They may not care about a tuition increase at that point. Whereas students that are freshmen starting off their first semester might be more concerned about it. And so by doing a convenience sample, you're getting kind of a local, you might be choosing people that don't really represent the entire population because you're only choosing people that are conveniently located around you. And that group of people might be different than the general population. All right. With stratified sampling, the sample is selected by dividing the population into at least 2 different subgroups based on shared, non-overlapping characteristics, so that one person cannot belong to 2 different groups, right? Then a sample is drawn from each subgroup. So, for example, if you wanted to do a survey at the high school, you could divide that population of high school students by grade. So the subgroups would be 9th graders, 10th graders, 11th graders, 12th graders, right? So you have to do at least 2 subgroups, but you could have more. And they're non-overlapping, right? You're either in 9th grade or you're in 10th grade. There's no in between. You can't have somebody that's in both, for example, either. All right. You can't have somebody that's both 9th grader and a 10th grader at the same time. And then you draw a sample from each subgroup. So then we would randomly select students from 9th grade, from the 9th grade group, randomly select students from the 10th grade group, 11th grade. So you get a sample by whatever method you want to use, but ideally you would do a random sample from each subgroup. And that's how you would collect your sample, your data, how do I want to say this? That's how you'd form your sample, and then you'd collect data from your sample that you've formed. Right, so that's stratified sampling. All right, let's take a look at another example, or another type. With cluster sampling, the sample is selected by dividing the population area into geographic sections, randomly selecting some of those areas, and then collecting data from every member of the population in the selected areas. So this one, it's very easy to confuse stratified sampling with cluster sampling, because in both cases, you're taking the entire population and dividing it in some way. So the difference here is that with stratified sampling, you're dividing your population based on a characteristic, a non-overlapping characteristic. Again, like the grade that they're in, 9th grade, 10th grade, 11th grade, 12th grade. With cluster sampling, you are dividing the population by physical location. So again, to use the high school as an analogy, it would be like dividing your population into classrooms. So you pick a certain time of the day, and then each classroom could be a different cluster, right? And so it wouldn't necessarily be by grade, because, some classes will have students from different grade levels in it, right? Depending, like some electives and whatnot, like a wood shop class could have a 9th grader and a 10th grader and an 11th grader. So you're not dividing them by grade, you're dividing them by just physically where they're located in the high school at the time that you're collecting your sample. So you divide it by classroom, and then you randomly select some classrooms. So the classrooms you pick have to be chosen randomly. And then once you've made those choices, you go to those classrooms and collect data from every student in the classroom. So you don't take a sample within that cluster. The entire cluster becomes part of your sample. So everybody in room 101, everybody in room 203, right? Whatever rooms got randomly selected, every student in those rooms would then be part of your sample. So that is how cluster sampling works. All right. So let's take a look at some problems. At a national conference of the American Appliances Association, a market research firm plans to conduct a survey of conference attendees. She uses the list of attendees' names and selects every 20th name on the list. Is the result a simple random sample? Why or why not? So maybe I feel like there's directions missing from this problem. So I think we're supposed to identify what sampling method is being used here, and then answer to whether it is a simple random sample or not. So what is the sampling technique that is being used? If you're, again, arranging all the names in a list one by one and selecting every 20th name, that is systematic sampling. That's like a conveyor belt, right? Except it's on a list instead of on a belt. So this would be systematic sampling, and this is never random. It's not random, it's not simple random. For reasons we already talked about. Okay, why is it not simple random? Because not every possible sample, now, because remember, simple random is about each group having the same chance of being selected. So you think of every possible, like let's say your sample size is going to be 100. You want to consider every possible collection of 100 people from your population, every possible permutation of having 100 people from your population. For it to be a simple random sample, each grouping of 100 people has to have the same chance of being the sample that you end up getting. That can't happen with this systematic sampling technique because, as I mentioned, you cannot have a sample where the 19th person and the 20th person are together in the same sample. That sample has zero chance of occurring. Whereas there's other groupings where you have like the 20th person, the 40th person, the 60th person, which do have a chance of being the sample that you select under this technique. And so different groupings have different probabilities of being the sample you get. So for simple random sample, what you really want to look for is, because usually these examples that are not going to be simple random, there's an identifiable group that has zero chance of being the sample that you get. So if you can find some grouping of people that have no chance of being selected as the sample, it's not simple random. So like I said, 19th and 20th person together in the same sample has zero chance of happening because of the method that's being used here. So it cannot be simple random. Okay. Now a Math Excel, or sorry, keep calling it Math Excel. My stat lab, when it asks you why or why not, and maybe we need to actually pull up an example of that because the wording can get kind of tricky with the way they ask those questions. Generally, you'll have 4 options for why or why not. And at a glance, it's hard to spot what the difference is between those statements because they're all fairly identical to each other. But usually there will be 2 that say, for example, is this a simple random sample? There'll be 2 that say yes and 2 that say no. Because what they'll do is they'll put the questions together. Yes, it's simple random because blank, or no, it's not simple random because blank, and there will be 2 yeses and 2 nos. So we already know the answer is no, it was not simple random. And then for the 2 no answers that are available, you have to look closely because the reasoning will be almost the same for both of them, but there will be some slight difference between them that'll distinguish one from the other. And you want to look for one that says something to the effect of, not every grouping of size n has the same chance of being selected, or maybe something to the effect of a sample containing the 19th and the 20th person has no chance of occurring. Something to that effect would be the one that you'd want to pick. So just look real closely. And again, if I'm your instructor, if you have any trouble finding the correct answer in some of those cases, please reach out to me and we'll do some examples. I can help you out. Determine whether the given description corresponds to an observational study or an experiment. In a clinical trial of the cholesterol drug Lipitor, 188 subjects were given 20 milligram doses of the drug, and 3.7% of them experienced nausea. All right, so is this an observational study or an experiment? Well, remember, for an observational study, the person conducting that study should have the approach of watching without modification, right? If you're doing an observational study, you don't want to make any changes to the situation. You just want to see people in their natural state behaving as they normally do, right? Based on whatever is going on. For an experiment, you are modifying the people in your study in some way, and then seeing how that modification affects them. So if you're talking about any kind of clinical trial for a drug, that will always be an experiment, because you are taking the people in your study, giving them some drug, and then observing to see how that drug affects them. Right? That is an experiment, because you are modifying those people by giving them a drug that they otherwise would not have had. Right? And so this would be an experiment in this case. Okay. Okay, and I was maybe hoping for an example of observational study. I always think of Jane Goodall, I think it is, the woman who studies, the scientist who studies chimpanzees, gorillas, as the quintessential observational study, right? Because she watches them in their natural habitats to see how they act. And she tries to be unnoticed because she wants to see how they would naturally act if people weren't around watching them, right? So that's kind of what an observational study should strive for. Identify which of these types of sampling is used. This is kind of what we did before with systematic. So here are our choices. We have random, systematic, convenience, stratified, or cluster. On the day of the last presidential election, ABC News organized an exit poll in which specific polling stations were randomly selected and, typo here, sorry about that, it should be an and all voters were surveyed as they left the premises. All right, so what's happening here is that their population is all voters, right? They're trying to understand the entire population of voters. And the way they collected their sample, the way they determined their sample was by, what did it say here? ABC News organized an exit poll in which specific polling stations were randomly selected. So polling stations are, designated geographically, right? So you try to have polling stations, throughout the town. Now in Dodge City, it's a small town. We tend to only have one polling station, one place where you go to vote. But in bigger towns, you have multiples of them. And if you live in a certain area, you go to this particular polling station, right? So they can kind of spread out the population. So what they're doing is they are picking specific polling stations, and all voters were surveyed at those polling stations as they left. So again, the population is being divided geographically speaking by selecting these different polling stations. You're really capturing the voter, you're really capturing voters geographically based on the polling station that they went to. So if you're surveying this polling station, that means you are capturing the voters in this particular geographic area in the city, right? So the population is being divided geographically by using these polling stations, and all voters at those particular polling stations are being surveyed. That's exactly how cluster sampling works, right? You divide the population geographically, and once you make your random selections, like they did here, they randomly selected polling stations, everybody in those selections is surveyed, right? Everybody in those geographic pods are surveyed for your sample. And so this is cluster sampling. Right. Okay. Identify which of these types of sampling is used. A manufacturer's procedure for quality control is to test every 100th spark plug from the assembly line. We're seeing this again. This is systematic. Right? I mean, it's literally a conveyor belt, right? It's an assembly line. And every 100th one is being tested. Again, that might seem like an arbitrary number to pick, every 100th one, but that doesn't make it random, because the 99th spark plug has zero chance of being in the sample. And so not every spark plug has an equal chance of being selected. And so it's not random, it's systematic in this case. Right. The author surveyed all of his students to obtain sample data consisting of the number of credit cards students possess. This is very similar to the example I gave earlier, that if I wanted to know how students felt about tuition increases, I could just ask the students in my class to get a sense of that, but it's not a very representative sample of the population. It's convenient sampling, right? I'm just picking the students that are easiest for me to reach out to, not doing it in a random way or a very scientific way, just out of convenience. The people that are easiest for me to reach out to become my sample. And so this is convenient sampling. I don't feel like writing the whole word out, so I'll just circle it up here, I guess. All right. In a study of college programs, 820 students are randomly selected from those majoring in communications. 1,463 are randomly selected from those majoring in business, and 760 students are randomly selected from those majoring in history. So this one, now you could kind of, pick at these divisions, because it is possible for students to have a double major. So maybe a student could major in communication and history simultaneously. But what they're going for here, even if it's not perfect, is they're going for stratified sampling, right? They're not dividing the population geographically. They are dividing the population based on a characteristic. In this case, that characteristic being the major that they have in college. And with the assumption that there's no overlap, right? Because we really don't want a student that could belong to both groups. So maybe if a student did have two majors, you could just say there's a primary major and a secondary major, and this is just the primary one. So you can only have one primary major, and that's how they decide which group you belong to. And so there's no overlap in that case. So you have to maybe, do a little finagling to make sure there's no overlap, but I'm sure it could be done. And then they are collecting a sample from each I can't remember the name for it, but each group that they've created. They're collecting a sample from each one. They're not collecting data from everybody in that group. That's not how stratified sampling works. You just collect a sample from each individual group. So a sample from the communication majors, a sample from the business majors, a sample from the history majors. And that's what they've done. They're not asserting that they've selected everybody majoring in communications, but only 820 students from the communication majors are being selected. And it doesn't really go into how, I guess it says randomly selected, right? But this is stratified sampling. So if the population is divided based on a characteristic of some kind, it's stratified. If they're divided by geographic location, that's cluster sampling. Okay. In a poll, 1,003 adults were called after their telephone numbers were randomly generated by a computer, and 20% of them said that they get the news on the internet every day. It's in the question. It's in the problem. So this is one of the funny cases where the answer is stated in the problem. It's a random sample. Because describing, a random sample is difficult to do. It's really difficult to achieve, honestly. How do you make something truly random? So if you go on the internet, there is a website called random.org, which purports to be able to generate random numbers for you. And their methodology is to, if I'm not mistaken, unless it's changed, is to base the numbers it randomly generates for you on atmospheric noise, which is fairly random. So whatever frequency they're looking at, they look at some kind of atmospheric turbulence, noise, whatever, and based on that, it's the seed that goes into the calculation that produces the randomness when it spits out a number. And because the seed is random, because the atmospheric noise is random, instead of trying to describe the process by which they tried to make it random. And so so basically, when will you pick the answer of random sample? If they tell you in the problem that it's a random sample, that's when you pick random. Because otherwise, I don't think they'd be able to do a great job of describing how that sample was collected without getting too technical. All right. So identify which of these types of sampling is used, random or simple random. A classroom is divided in half. So in fact, I kind of want to talk about maybe not is it random or simple random, but maybe I've kind of typed this question poorly. Is it random? Is it simple random? So let's answer both of those. Is it random? Is it simple random? A classroom is divided in half. 3 students will be randomly selected from each half for a sample of 6 total students. So imagine being in a classroom, like when we're in my classroom, so I don't know, if we have face-to-face classes, which currently I think we are supposed to, but I don't know if that'll change in the future or whatever. But even if we are having face-to-face classes, but you are watching this from home, in my classroom, there's a nice division between the left half and the right half. So there's stairs right here. It's like a stadium style class. It's a small classroom, but it does sort of have stadium style tiers, you know? So there's stairs down the middle, and there's seats over here, there's seats over here. And it doesn't always happen that I have the same number of students on either side. But let's say I took my classroom, however many students I have, let's say I have like 20 students, which is kind of a lot for statistics. We usually don't get that many. And so I'm going to say we're going to put 10 students over here. So I have 10 students sitting over here and 10 students sitting over here. Right. Now the way I'm going to collect my sample, so by dividing it in half, I have an equal number in each group. Right. So I have two groups I've divided it into. It's kind of like, it's not really cluster sampling because I'm not going to like randomly select a geographic location, but it's not stratified sampling either because I'm not dividing my students based on any characteristic. I'm just saying half of you sit over here, half of you sit over here. And then I'm going to randomly select 3 students from this side of the room and 3 students from this side of the room. And so I'll have a sample of size 6. So commonly the sample size is represented with the letter N. So N will be equal to 6. Now I put N equals 20 here, but that's really my population. So I should have used capital N for that. Now, is this random? So we haven't talked about probability yet. I was actually just working on my presentation for that chapter, which is chapter 4. So it's going to be a while before you guys get to that. But students usually have a pretty good sense of probability. So if you're one of the 10 students sitting over here, and I'm going to pick 3 of you for my sample, what's your probability of being selected for the sample? It's 3 out of 10, right? It's 3/10. It's 30%, right? That's the same thing as 30%, right? So you have a 30% chance of being selected if you're sitting on this side of the room to be in my sample, because I'm just going to randomly pick one of you so everybody has the same chance of being selected. 3 of the 10 of you are going to get selected, so you have a 3 in 10 chance of being in my sample. Same thing over here, right? So your probability of being in my sample, if you're sitting on this side of the room, is 3 out of 10. So each person on this side of the room has a 3 in 10 chance of being selected. Each person on this side of the room has a 3 in 10 chance of being selected. So it's random. Everybody has the same chance of being selected. Everybody has a 30% chance of being in my sample. So in this case, it is random. But is it simple random? Because remember, random, you're looking at the individual. Does each individual have the same chance of being selected? In this scenario, yes. Each individual has a 3 in 10 chance of being selected for the sample. So it's random because everybody has the same chance of being selected on the individual level. But for the group level, is it equal? So is it a simple random sample? Does every possible combination of 6 people in my class have the same chance of being selected for this sample? So if I have 20 students altogether, if I took every possible configuration of 6 out of that 20, would every possible configuration have the same chance of being the sample that I end up getting of 6 students? And the answer is no. So for example, could I have a sample where all 6 students were chosen from just one side of the room? The answer is no, because the method is I'm only picking 3 from the right-hand side and 3 from the left-hand side. So I can't have a sample where all 6 students came from the right-hand side of the classroom. And so that's a sample that has 0 chance of occurring. So like I said, for simple random, you really want to be looking out for, is there a sample that has no chance of being the sample that I kind of said that funny. Is there a group that has 0 chance of being the sample that you end up getting? And in this case, if I take 6 students from just one side of the room, that group has 0 chance of being the sample that I get, because I would never choose 6 people from that side of the room. I'm only going to choose 3. So a group of 6 people from that side of the room has no chance of being the sample that I get based on this method that I'm using. And so it is not simple random. So it's kind of, you have to do some acrobatics here, but it is possible to have scenarios where it's random, but not simple random. Right. Otherwise, I would suggest, again, this might not be a universally correct rule, but I would suggest on these problems, because there's going to be a couple of these problems on the homework. And if you cannot think of a sample that would have no chance of occurring and it's random, it's probably also simple random. So that's what I would really look for, is first check to see if it's random. And I also want to say that if a sample is not random, I don't think it can be simple random, but I could be wrong about that. But check to see if it's random, meaning does each individual have the same chance of being selected for the sample? And if that's the case, for simple random, consider, are there any groups that have no chance of being the sample that I would get? And if there are any groups that have zero chance of being the sample, then it is not simple random. But if you cannot think of any groups that would have zero chance of being the sample you get, then it's probably also simple random. And I think you'd be safe answering in that way. Even though, like I said, that might not universally always be correct. I think it's good enough for what you're going to come across in this class. So this was kind of another short section. So we're at the end of section 1.3. Thank you for watching. We will not be having a test on chapter 1. We will be having, if you're in my class, we do chapter 1, 2, and 3 before we have a test. So what you should do next is move on to section 2.1. So I'll see you in the video for section 2.1.